be sure to hit that subscribe button and click on that bell notification icon so you don't miss out on any updates from us. So in the agenda, we have firstly, we're going to be discussing what Spark is to get an idea of it. Then we're going to be discussing why Spark is important for big data. And then eventually, what you guys are here for, how to access the data files in Spark. And then once we've accessed those data files, we're going to be learning how to actually query the data frames that we create from those data files. So let us begin. So firstly, what is Spark? So if you're watching this video, you probably have some idea of what Spark is, but for those of you guys who don't actually understand, Apache Spark is an open source framework that has been developed for cluster-based programming. So what cluster-based programming means is that there's not a single node in a system. There's not a single system that you're dealing with. You're dealing with a collection of systems across a server. So it's a combination of computers. Together, they form a cluster. So this is usually what is used for analyzing huge amounts of data, because one system isn't enough to do that. So we combine a lot of computers together, a lot of nodes together, as we like to term it, in cluster-based programming. And then we process the same data in a considerably less amount of time. So that is cluster-based programming and computing. So it was originally developed as an upgrade to Hadoop's MapReduce framework. So Hadoop was what was initially used to analyze big data, but MapReduce is a lot slower than Spark. That is why we use Apache Spark and not MapReduce in the modern world today. So why is Spark so fast, and why is Spark so beneficial? So as we can see, big data, originally it was analyzed using Hadoop MapReduce. So what Hadoop MapReduce does is every time it is generating an output or an intermediate output, it reads and writes files from the disk. So disk could mean the hard drive that you have on your computer, or the hard drive that is there on the server. So this reading and writing operation, this takes a lot of input-output overhead. So that is time that basically adds up to the time that we get our output within, right? So that is why the desired output that we receive by using Hadoop MapReduce is after input-output delays. So it's considerably delayed, right? But it was what was originally used. But after the introduction of the Spark engine via Apache Spark, Spark started to emphasize on in-memory processing and the usage of shared variables. So what does in-memory processing mean? So memory here refers to the RAM, or in other words, the random access memory, right? So the CPU is directly connected to the RAM, and when data is present within the RAM, the latency is almost zero. So the time it takes for the CPU to access that data is almost instant, right? So the overall reduction of not having to read and write every time there is a processing procedure going on, that considerably reduced the time, and that made Apache Spark about 100 times faster than Hadoop MapReduce. At least where large amounts of data is concerned, because in smaller amounts of data you wouldn't notice the difference, but when you're dealing with a large amount of data, a little bit of input-output delay could add up, and that is why in Apache Spark, when we're dealing with a large amount of data, we notice the difference. So the other benefit of using Apache Spark is that, as we can see on the upper side, normal data can be processed by vanilla, the base versions of Java or Scala or Python and R. So all of these are quite frequently used data science / data analytics language. So if you have, say, a very small data set that you need to process, right? So you can use these particular languages in their base form. What happens if you're dealing with terabytes and petabytes of data, but you still want to use these same languages? You cannot use them in their base form, right? So Spark, Apache Spark, as we were discussing before, provides APIs. So for these well-known data analytics languages like Java, Python, R, and Scala, Spark provides APIs. So you can basically start up a code file out of any of these languages, just import the Spark library, and basically use the same language as you were using earlier for analyzing your normal data. But in this case, just by using the Spark libraries, you can analyze big data as well. All of the background tasks of how it is being maintained inside a cluster computing framework is being managed by Apache Spark. So you don't need to worry about that. That is completely abstracted, right? So without learning anything new, without actually having to train for any big data technologies or having to understand even how cluster computing frameworks work, right? You can simply use your knowledge base in Python and get started with big data. So that is one of the key advantages of Spark as well. So let us now get on to how to access data files. So I'll be showing you a brief hands-on on how to access the data files, and then we'll eventually move on to querying the data files. So accessing a data file is actually quite simple. Simply create a document first, right? So you can do this with the command line as well, but I'm doing it with some visual interface just to tell you guys how it actually works. So let's call this example.txt, right? So once you've created that, you can simply open it up and type anything you would like. So in our case, let's just type hello from Intellipaat. So this is just basically a data file, right? This is unstructured data in a way. There's no order to it. It's just a basic sentence. So if you want to convert this into a Spark JVM object, you'll simply save this first, right? Close this up. So this is also the present working directory that we have. So here is the file. Simply open up a terminal. So this is a terminal. I'll just expand the size for you guys so you can see. Yeah. So there. The first thing that we would do is obviously start the Spark shell, right? So the Spark shell by default starts in Scala. So it is a Scala shell with the Spark libraries already imported. So it takes a bit of time to start up, but it starts up. Yeah. So the Spark session is available as Spark, and the Spark context is available as SC. So this is a variable that we would be using to invoke the Spark context, right? So the thing that you would do is create a variable. I'll call this RDD, right? And equate it to the sc.text file. And given the location for where you want to take your source file from. So in our case, it would be from the present working directory, which is home training, and the file name, which is example.txt. Given the double quotes again, and close it up and press enter. So that would create the RDD out of that particular text file. So that is how simple it is to basically take a raw text file or a raw data file and convert it into a Spark RDD. So now we have reached the querying part. So let us see the exact procedure that Apache Spark follows for this data file querying. So as we can see, the way we achieve data querying is by converting the raw data that we have. In other words, the data files that we were referring to earlier, we basically convert them to data frames, and then we run normal SQL queries on them. So the definition of a data frame is it is a data set organized into named columns. It is conceptually equivalent to a table in a relational database or a data frame in R Python, but with richer optimizations under the hood. So to explain that in brief, it basically means that Spark data frames are equivalent to SQL tables, right? The relational database tables, or you could basically equate them to data frames that you would normally create in R and Python with vanilla R and Python, mind you. So it is basically equivalent to that. But the richer optimizations here implies that it is optimized for cluster computing. these are not normal data frames that are present within one system. These data frames could be present throughout multiples of systems on multiples of nodes in a cluster. So, and you wouldn't even notice the difference. You are just seeing it from one point of view where you see the entire data frame in one page, right? So that is the difference between a normal data frame and a say R/Python data frame, right? So the procedure here, as we can see, raw data, which could be semi-structured, unstructured, or even structured at times, data, it's first converted into a Spark JVM object, right? So there are essentially two types of Spark JVM objects. Spark obviously uses JVM objects because it is an object-based framework. So one of them are RDDs, and the other is data sets. So you can basically convert them into JVM objects, the data that you have. So these could be arrays and whatnot, right? So once you have these arrays based out of the raw data that you've generated earlier on, you can convert these arrays into named columns, and those named columns are then called Spark data frames, which is our target anyway, right? So once you've converted them into Spark data frames, which are SQL-like tables, naturally you should be able to run SQL queries on it, and Spark actually allows you to do that because Spark provides the SQL context, which means you can pass string values which are equivalent to SQL queries that you would normally pass in, say, MySQL, and then basically analyze the Spark data frame that you have like an SQL table, and then get your query results as is. So that is how much Apache Spark simplifies analyzing big data. It brings it down so that a normal person who has experience in relational database management systems can use Apache Spark very conveniently without having to learn a lot of new things, right? So these are one of the advantages of Apache Spark, the accessibility that it provides, right? So as we can see on the bottom, Spark SQL context is created to run string-based SQL-like queries on Spark data frames. So as we discussed earlier. So now let us perform some SQL queries using the SQL context that Apache Spark provides on a freshly created data frame. So let us begin. So now let us take an example at a real life data set. So we'll be looking at a comma separated file, a comma separated value file, a .csv file. So this is yellow.csv. So what does yellow.csv have? So in order to give you a brief introduction to the dataset, it's basically a taxi dataset, like a taxi trip dataset. So you have your pickup date times and your drop off times and the total duration of the trip and the total distance of the trip, where the passenger was picked up and where the passenger was dropped off. So all of these things basically, and the distance between all of the trips and the amount, the fare and everything. So you can think about this as a taxi data that has been generated for the well-known taxi apps that you may be using on a regular basis. Well, not these days because of the virus, but in other ways. So Ola and Uber sorts. So this is basically the data that they're generating on a day-to-day basis. So if you just scroll down, we can see that this somewhat qualifies for a big data use case, right? And we're going to be actually running some queries on this data set. So firstly, this is in a semi-structured format, a CSV file. We are going to be converting this into a data frame before actually performing queries on it, right? So let us just quickly minimize this, or you can just close this off as well, works the same. And open up our terminal, right? So let us continue from where we left off. So open up the terminal and expand this, right? So firstly, we are going to be actually importing our taxi dataset, which is the yellow.csv. Right? So let's create a data frame out of that. So we'll call this data frame df and simply type in Spark, which is the Spark variable that has been created, the session variable, dot read, and that then we'll give a simple dot format and specify the format of the file. In our case, it's a CSV file. Type in CSV for that. Close that up Now you can give certain options to this. So we'll firstly give that we actually want the header. So the header is the first row that is present in each CSV file. So we want the header to be there. So we will simply give a header as true. We'll give some other options as well. We want this to be treated as a schema, so we'll do that as well. So this is a simple option for that. And for schema, we'll give this the Boolean value of true. Right, and then simply type in another option. You can keep on typing options, as many options that you would like. So you can, once you would actually start to understand Spark, you'll understand how many options there actually are. And given a mode for memory management purposes, so I'll give this a fail fast mode. And then simply type in the location of the file. So type in .load and given the location of the file. So in our case, home training yellow.csv, and close this up. And once you do that, it will automatically create a data frame out of that CSV file using the comma separated value functionality, and press enter. So it takes some time to load it all up. So, but once it loads it up, there's no delay and latency after that, because it is essentially loading it up inside of the RAM, right? So let us now continue with this. Firstly, we'll actually not call this the DF. We'll create a temporary view out of this DF so we can refer to it in the SQL context that we would invoke later on. So we would be renaming this table essentially and not calling it DF. This is an optional step, but it's for better readability of code. So it's always recommended. So create or replace temp view. And you can call this anything. In my case, I'll call this taxi data, and then close it up. Press enter, and it will create the new view, right? So after, we are basically referring to it as taxi data from now on whenever we use the SQL context on this particular data frame, right? So say now we can run some queries on it. So let us think of a query. Say we want to find out the total number of trips that have been taken throughout the data set, right? Simple. Simply invoke the Spark session variable, type in .sql. So we are now invoking the SQL context as well. And it's simple as anything. You can simply start a string value or double quotes and type in what you would normally type in MySQL, right? So how would you do it in SQL? Select, and then you will type count. Count is a function in SQL. And star, so you want to count all of the records, so you're typing in star, so all of the rows, basically the number of rows will be counted except the header. And type in from, and the alias that we just provided it earlier, which is taxi data, we'll call it taxi data, and simply double quote close and close this up. And what this will do is basically, and when you type in .show, this will show you the result out of that SQL query. So you will get what the MySQL would have shown you normally. So in this case, for big data, press enter, it will give you the count, right? So in our case, we have about a 10,000 number of records, basically. So we get that. Now, say we want to get a little more complex, right? So now we want to find out the total number of the total revenue that is generated, right? So the total revenue that would be generated from all of this would be the sum of the column, that is the revenue column. So if we just simply see how this is working, if we type in df.show and type in 3, so we want to see 3 records to get an idea of how the columns are working. Press and enter. So as we can see, the record that we want to refer to is the total amount, right? So this is the amount. So this particular column, we want to add up all of the values in that and finally get the value at the end of it that we would like, right? That is what we want to do. So let us just simply do that. So we know the column name that we want to refer to. So if I simply type in spark.sql and type in select sum, and then type in the column name that I would like to use the sum for, which is the total amount as we saw in the column name, right? From the temporary view, which is taxi data, close this up, press enter, and it will show you that. So actually I didn't type in show. If you simply type in show, it will show me the actual output of that, and press enter. So now as we can see, the total amount, the sum of the total amount is about $160,000 or rupees, whatever the amount is in. That is irrelevant at the moment. But yeah. So say if we want to actually do something else with this. So say we want to find out a particular fraction, right? We want to find out how much is out of this total amount that we have, the total amount that we've calculated, how much out of this is toll revenue, right? So that is also simple. Simply type in spark.sql, select sum of the toll amount. So here's the tolls amount that we have. So it's TOLLS underscore amount. So it has to be exactly that. So the total amount of toll divided by the total amount of total amount, right? So we get that, and out of the taxi data. So this will give us the value that we require. Type in .show after that and press enter. So as we can see, the fraction that we have is about 1.5%. So as we can see, it's about 0.015. So that is the fraction basically about with the ratio of the toll amount and the total amount basically. And from here on out, it's basically simple SQL. So now you know you only have the only Spark aspect that is coming into it, as we had discussed earlier before. If you're coming from an RDBMS background, the only new thing that you really have to type is this spark.sql. The rest of it is basically the same. And if you want to take out the average amount for each of the trips, you can simply type in select and then type in AVG, and given the column name that you want to calculate the average of. So AVG is also a function that is present in SQL by default, and given like from taxi data. Close this up and type in .show. So this will give you the average amount. So the average amount for each of the trips is 16 units or $16. And if you want to get a little more complex than that, so say if you want to use the group by clause that is present within SQL, you can use that as well. So if I simply scroll up, we can see that there's a payment type, right? So the payment type and the data description is basically in categories like 1, 2s, and 3s. So all of this is there, right? So if we want to arrange particular results according to the payment type, we can do that as well as we would do in normal SQL. So if we type in spark.sql, say we want to arrange the average, say the average, any column name that we can pick up right now, the fare amount, say if you want to pick up the average fare amount that we're picking up, right? And we want to arrange it by the payment type. So the payment type could happen online, offline, like you pay cash, sometimes you use online wallets, sometimes you use cards. So basically all of those things have been mapped to particular numbers like 1s, 2s, and 3s. So that is not relevant to us right now. What we want to do is basically arrange it according to the payment type, right? So simply type in select the payment type, because you need to select the column name that you are grouping the entire query by. So the payment underscore type is the column name that you absolutely want in your result. And then simply type in the average of the fare amount. So the fare underscore amount, it has to be the exact column name that you're using. And then what you could do is simply use from taxi data, but that doesn't end there. You have to also group it by payment type. So at the end of it, simply type group by payment type, close this up, and put a dot show at the end of it, and then press enter. So that was actually an issue because we mishandled the column name. Simply type in an underscore after that because that is the actual column name, and then press enter. So as we can see, there are basically 4 payment types that we had, 1, 2, 3, and 4. So all of these could have been mapped to anything. That is not relevant to us right now, but what we know is for each payment type, we have gotten the average fare amount, right? So we can use group by as well. And if you want to go into even more complex territory, we could take a query like which hour of the day on average makes the most amount of revenue, right? So the way we would go about that is simply invoking the SQL context once again. And here we're going to be making a nested SQL statement. So if you're familiar with SQL, you would understand this. We're going to be using aliases in this. So say the first alias we would be calling h24. So h24 would be what our nested SQL query would be. And as R, we also need the average of the total amount for this. So make sure all of these names match. So we're also assigning an alias to this, which is average revenue from, and this would be the nested SQL statement. So this is also a select statement inside of this. Select R, the pickup date time. We'll just look at the column name for once. Just simply scroll up and look at the column name. What is it actually called? The pickup time. So we have the tpep underscore pickup underscore date time. So simply copy this, right? So copy this, and once we scroll down back, erase this and paste it over here. So we have our pickup date time. So this is basically the pickup time of when the trip started, right? So we actually entered our pickup time. Close this up. And refer to this as h24, which we were referring to before over here, right? So our pickup time is h24. The total amount involved in this for each particular hour, basically each particular pickup time, from taxi data. So first thing that we would do is obviously group it by h24. And order all of this. So basically ordering means sorting all of the results by the average revenue, which is the alias for the average of the total amount. And if you don't specify the DESC right here, then it'll basically order itself in the ascending order, but we want the highest revenue that is generated. So we'll arrange it in descending order. So we get the first result first, right? And then simply close this up and type in dot show and press enter. So as we can see, the R number 22 has the highest average result, average revenue. So the 22 would basically imply the 10 p.m. mark. So in the 24-hour clock, in the 10 p.m. mark, we have the highest revenue, right? So that means 10 p.m. In this particular taxi organization's business, 10 p.m. is the most profitable. So that is basically what the average big data use case statement is. So you'll be asked by your employer to basically calculate these particular insights. So say now that you have that information, you know that you're going to be encouraging your cab drivers to be really active around that time, the 9, 10, 11 p.m. mark, because that is when you get the most revenue and the most profit out of it, right? So out of that. So as we can see, it is simply arranged in that order. 0th means the 12 a.m. mark, the 23rd means the 11 p.m. mark, and the 22 means the 10 p.m. mark. So these 3 hours are the most profitable in that particular order, right? So this is basically what you can do with Spark and the Spark SQL context. And by converting normal unstructured or semi-structured data formats to a data frame and simply running what you would run in an RDBMS system, but for big data. So now that you understand how Apache Spark essentially works with the SQL context and everything, if you're looking to get into the technology, there are multiple ways for that, right? So you can look up some online resources, right? There are obviously a lot of resources available online for big data analytics. We have recently started the Intellipaat blog, so you can look into the Intellipaat blogs. We've discussed a lot about Apache Sparks over there. Or you could also check out videos on YouTube, including ours, because we've also conducted courses on Apache Spark on YouTube. But the best way to go about it, in my opinion, is actually getting that data, getting that information, that learning experience, and having the most amount of retention possible. And the way for that is actually opting for an organized course if you're genuinely looking to expand your knowledge base into this particular domain, right? So for that, if you just head on over to intellipaat.com, so here, as you can see, we can simply type in Spark in the search box of our course searches. And if you're solely looking for the Spark course, you can opt for the most popular Spark course that we have on our website, which is the Apache Spark and Scala certification training. So I'll just guide you through all of the key benefits that are involved with this particular course. So as we can see, what you learn in this particular course is the Spark streaming, Spark SQL, Spark RDD, and Spark ML libraries. So the Spark ML. So similarly, as you would perform some machine learning with Python, Spark also provides you libraries for that. So the key features for this course, one of it is that there's a free Python course attached to this. So you will get a Python course for absolutely free because we will be implementing Python in this particular course. You will get that for free. And the other key features would include 24 hours of instructor-led training. So that would mean that you would be seated in live batches or classes, and you could ask all of your doubts live from the instructor while the instructor is teaching. There's also 22 hours of self-paced videos, which implies that if the instructor is not going according to your pace, whether too fast or too slow, you can basically go and watch our video bank in this particular topic. It's about 22 hours worth, and basically collect all of your doubts and then ask the instructor or our support team for that matter. And then there's 60 hours worth of project work and exercises. So the best way to absolutely learn any technology is by implementing hands-on. So we provide 60 hours worth of hands-on for our particular course. Then there's certification and job assistance. So once you complete the course, once you get certified in the course, while we may not be able to guarantee you a job, we most certainly will be able to guarantee you an opportunity. So depending on the performance that you have in the interview, you can land the job that you want. And then there's a flexible schedule. So say if the instructor's schedule does not match with yours on a particular day, you would be seated in the next batch, but you will not miss out on that particular live class. And then there's a lifetime free upgrade. So that means that if there's a technology upgrade, if there's an update in this technology that is significant, we update our courses as well. And the updated course will be provided to you for absolutely free, no cost extra. Right. And then there's obviously 24/7 lifetime support and access. So any doubts you have, technical or non-technical, it will be resolved for you. So if you want to look into detail as to what will be taught to you in this particular course, you can see over here, which is the Apache Spark and Scala programming. So very essential to that. We firstly teach Scala programming, and then we head on over to Apache Spark. And then the difference between Apache Spark and Hadoop, so you understand where to use what, Scala and the programming implementation for that, and implementing Spark on a multi-noded cluster, and then using Spark alongside Python, Java, and Scala, RDDs and how they operate, Spark streaming, and Scala classes concept infused with Apache Spark, and the interoperability of Scala and Java, and working on projects, these Spark projects using the Scala programming language. So you can take this course up if you're coming from particular domains, software engineers, who want to get into the field of big data, data engineers and ETL developers, data scientists and analytics professionals, and graduates who are fresh out of university and looking to make a career in big data. The prerequisites for this particular course are absolutely none. But it helps if you have basic SQL knowledge, because you would be actually implementing SQL a lot since it is a data analytics course. And you can basically take this course up because Spark is an up and coming technology. It's already being used by most organizations instead of Hadoop MapReduce. So it is the better alternative compared to Hadoop. So that is why Apache Spark is a very relevant technology today as well. So if you want to look into the syllabus in detail, you can download the curriculum and look at the course content, expand all of these sections, and look at the exact material that would be taught to you. And you can basically look at what projects you would be doing at the bottom of the page here, right? And especially for our YouTube audiences watching us here today, if you use the coupon code YouTube30 on our course page, you can get a flat 30% discount on not just the Spark and Scala course. You can get it on every course that we provide. So if you're looking to opt for anything, be sure to use this coupon code to get a flat 30% discount. And that's about it from us. You can contact us using the following contact details: our sales team and our course advisors as well, if you're looking to get some insight into what is the appropriate course for you. And be sure to sign up for our webinar, the link for which has been provided to you in the YouTube chat box. If you sign up for the webinar, you'll be able to ask doubts from the instructors live, and the instructors would respond to you. And you can basically get some personal treatment out of that. So be sure you sign up for the webinar. So with that out of the way, that's about it for today. Hope you have a wonderful day ahead of you. Goodbye from Intellipaat.